In this example, I want to write equations from which I can find the current I using two different approaches. In the first part, I'm going to use constrained loops. Next, I'll redo the problem without constrained loops. So if I'm going to use constrained loops, I'll kill my sources, identify resulting enclosed non-overlapping areas, and my mesh currents, which are my unknowns, will go around the perimeters of those areas. If I do that for this circuit, I'll end up with a mesh loop that goes around this area. I'll call that I1. A mesh loop that goes around this area, I'll call that one I2. And a mesh loop that goes around this area, I'll call that I3. Now I need to define a constrained loop that will account for this 4 amp current source over here. So the constrained loop has to match the magnitude and the direction of the current through the current source. I think I'll go this direction and loop around this side of this circuit. The magnitude of that current has to be 4 amps. Now let's write our equations. First, let's write KVL around the loop defined by the mesh current I1. If I start down here and go this direction, following this direction of my mesh current I1, I see the negative terminal of the 3-volt source first. So that's a negative 3 volts, plus this voltage across the 2 ohm resistor is going to be its resistance, 2 ohms, times the sum of the mesh currents, which is just I1. And then the 7 ohm resistor, 7 ohms, has mesh currents I1 entering the assumed positive terminal and I3 entering the negative terminal. So that'll be a common I1 minus I3. That brings me back to my starting point, so that equals 0. Now let's loop around the mesh current I2. That's this current up here. It's going clockwise. So if I set up my sign convention such that the mesh current I'm following, I2, always enters the positive terminal, the voltage across the 3 ohm resistor is 3 ohms. Since I2 is entering the positive terminal, that's a positive term. That's the only mesh current that's going through the 3 ohm resistor. Next, I come around here to the 10 ohm resistor, so plus 10 ohms. Times I2, I'm still using the sign convention where I2 enters the positive terminal. The 4 amp constraint over on this side of the world is also entering the positive terminal. Then coming around here, I see the negative terminal on the 6 volt source next, so minus 6 volts, that sums to 0. Now let's follow mesh current I3. If I start down at this lower terminal here and follow the direction of I3, the first thing I see is my assumed positive terminal on a 7 ohm resistor. So its voltage difference will be 7 ohms times the currents through that resistor. I3 is entering this positive terminal, so that's a positive contribution. And I1 is coming into the negative terminal on the 7 ohm resistor. It's in the opposite direction as I3. Now if I come around here, I see the positive terminal on the 6 volt source next. And then finally, coming around to the 5 ohm resistor, that voltage difference is 5 ohms times the sum of the currents. If I assume this is my positive terminal, I3 is entering that terminal, and the 4 amp constraint is also entering that terminal. So that's going to be I3 plus 4 amps. That brings me back down here to my starting point, so that sums to 0. Now I need an equation to give me the current I. I is positive in this direction, so it's in the opposite direction from I3. So I is going to be equal to the negative of I3. The other current that goes through this 5 ohm resistor is the 4 amp constrained current, which is also in the opposite direction from I. So I need a minus 4 amps for that as well. There are my 4 equations and 4 unknowns. I can solve those for I. Now let's write equations from which we can find the current I without using constrained loops. If I don't use constrained loops, I'll define this as a mesh current. I'll call that I1. This is a mesh current. I'll call that I2. This is a mesh current that I'll call I3. And then instead of using a constrained current over here, I'll call this another mesh current that's I4. So I don't kill my sources and my mesh currents go around any enclosed non-overlapping areas that are originally in my circuit. Now if I don't use constrained loops, I do have to define my voltages across current sources as unknowns. So I need to define the voltage, I'll call it V sub x, with this assumed polarity across the 4 amp source. Now let's write equations for the 4 mesh currents. For I1, if I start down here and go in this direction and do my usual sign convention thing, I get a negative 3 volts plus 2 ohms times I1 is the only mesh current going through the 2 ohm resistor, plus 7 ohms times I1 minus I3. I3 is in the opposite direction from I1. That sums to 0. For mesh current I2, if I start over here, I see the 3 ohm resistor first, so its voltage is 3 ohms times the sum of the currents. The only mesh current through the 3 ohm resistor is I2. That puts me over here by the 10 ohm resistor, so that's plus 10 ohms times the sums of the currents in that resistor, which will be I2 minus I4. In this leg here, I4 is going in this direction. It's in the opposite direction as I2. Then I see the negative terminal on the 6 volt source, so I subtract that. That brings me back to my starting point. Now let's loop around mesh current I3. If I start down here at the bottom, I see the 7 ohm resistor. The sum of the currents through there are I3 minus I2. Following this loop around here, I see the positive terminal on the 6 volt source first, so I add 6 volts. Then my last element is the 5 ohm resistor. Its voltage difference is 5 ohms times I3, and I4 is going in the opposite direction in this resistor, so I subtract off an I4. That sums to 0. Now let's loop around mesh current I4. If I again start down here and go this direction in the same direction as I4, I see my 5 ohm resistor. The sum of the currents there is I4 minus I3. The next element I see is the 10 ohm resistor, so that's plus 10 ohms times the sum of the mesh currents, which is I4 minus I2. Then when I'm coming down here, I see the positive terminal on V sub x next, so I add the voltage V sub x. That brings me back to my starting point, so those sum to 0. Now I have 4 equations with 5 unknowns. The unknowns are the 4 unknown mesh currents plus the unknown voltage across the current source V sub x. So I need one more equation, which will be my constraint equation. I know that over here the current through this element has to be 4 amps in that direction. I4 is the only current that goes through that source. It's positive in this direction, so I4 is equal to negative 4 amps. Finally, I need an equation for I. I is just equal to the sum of the currents through the 5 ohm resistor with this being positive, so I is equal to I4 minus I3.